The Monty Hall problem is a famous problem in probability, and the reason it's so famous is because the solution, or the best strategy to use, is counterintuitive. The problem is loosely based off a segment in a game show Let's Make a Deal, which was hosted by a man named Monty Hall, which is how the problem got its name. So it's stated as follows. Suppose you're on a game show and you're given the choice of 3 doors. Behind one door is a car, behind the others, goats. You pick a door, say number 1, and the host, who knows what's behind the doors, opens another door, say number 3, which has a goat. He then says to you, do you want to pick door number 2? Is it to your advantage to switch your choice? So if you want to try to solve this problem and find the best strategy, pause the video here. The solution to the problem is, yes, it is to your advantage to switch, because switching gives a 2/3 chance of winning, whereas staying gives a 1/3 chance of winning. So the common misconception is that if there are only 2 doors left and the car's behind one of those 2 doors, then it must be a 50-50 chance. But this is not the case. I think the best way to explain the solution is just to run through all the possible scenarios. There aren't that many, so it doesn't take too long. So firstly, the car can be behind door 1, 2, or 3, and you can choose door 1, 2, or 3. So this gives 9 equally likely scenarios. Then you choose your strategy. You either stay or switch. So let's say the car's behind door 1 and you choose door 1. Then Monty Hall has to open up one of the doors. So he either opens up door 2 or door 3. Either way, if you stay with the car and win. If you switch, you'll switch to a goat and lose. However, if you were to choose door 2, then Monty Hall can't open up door 1 because that has the car behind it, and he can't open up your door, so he's forced to open door 3. Therefore, he'll give you the option of switching to door 1. So if you stay, you'll stay with your goat and lose. If you switch, you'll switch to the car and win. Similarly, if you were to choose door 3, then Monty would be forced to open up door 2 because he can't open up the car or your door. So if you stay, you'll stay with your goat and lose. If you switch, you'll switch to the car and win. So we can fill out the rest of the table using the same logic. So if using the staying strategy, you win 3 out of the 9 scenarios. If you use the switch strategy, you win 6 out of the 9 scenarios. So staying gives a 1/3 chance of winning, whereas switching gives a 2/3 chance of winning. Another way to solve this problem is to extend it and then generalize it. So I think the main confusion with the Monty Hall problem comes from there being 3 doors, because that actually means that eliminating one door is really the same thing as eliminating all of the doors, except for yours and one other. So to see what I mean, let's imagine that there were 10 doors, and let's say you picked door 2. Well, if you picked the car initially, then all of the other 9 doors have goats in them. And if you picked a goat initially, then 8 of the other 9 doors have goats in them, and one of those has a car. Either way, Monty is able to open up 8 doors to reveal goats. So let's say he opens up these 8. Then he asks you if you want to stick with door 2 or switch to door 6. Well, there are only 2 scenarios here, so either you initially pick the car, that's a 10% chance, and if you did, you'll want to stay. The second scenario is that you initially picked a goat, that's a 90% chance, and if this happens, you'll want to switch, because if you switch, you'll switch to the car. Now let's extend the problem to 100 doors. Let's say there's 1 car and 99 goats, and after you make your initial selection, Monty Hall will open 98 doors revealing goats. If you're going to use the staying strategy, the only way to win is to initially pick the car, and that's a 1% chance, so staying only works 1% of the time. However, if you're going to use the switching strategy, then you actually want to pick any other door, because as long as you don't initially pick the car, that means you picked a goat. And if there are 99 goats and you've got 1, and Monty Hall has to eliminate 98, then the door he'll offer you the chance to switch to must be the car door. So as long as you don't initially pick the car, you win by switching. So switching works 99% of the time. Now that we've done it for 10 doors and 100 doors, we can generalize it to any number of doors. So let's say there are n doors containing 1 car and n minus 1 goats. And again, after your initial selection, Monty will reveal n minus 2 goats and leave only your door and one other door unopened. So in this case, you can only win using the staying strategy if you initially pick the car, and that's only a 1 over n chance of happening. If you use a switching strategy, then you initially want to pick a goat, because then you'll be given the option of switching to the car. And the probability of picking a goat is n minus 1 over n. So we can see in the Monty Hall problem there are 3 doors, so n equals 3. Therefore, staying gives a 1/3 chance of winning, whereas switching gives a 2/3 chance of winning. And that's 2/3 because it's 3 minus 1 over 3. So that's it. I hope this helped you understand the Monty Hall problem. If you enjoyed this video, please like and share it. Thank you.